Hello guys, welcome to Ahuja's Maths Academy. Let us continue our topic real numbers, and this is the continuation of the last topic covered in my last video. So this is the proof that the following numbers are irrational. Here I have selected some different numbers. Root 5 is the example based on root 2. Root 3 you do on your own. I am taking root 5. So let us assume that root 5 is equal to root 5 is rational. Let root 5 equal to a upon b, where a and b are co-prime numbers. That means a and b do not have any common factor. Now similar as we did earlier, this is just repetition. Now multiplying both the sides by b. So root 5b is equal to a. Squaring both the sides. Root 5 square is 5, b square is b square, a square. Now here you see that 5b square is equal to a square. That means a square has two factors. One is 5 and the other is b square. This shows that, or this implies that 5 divides a square. That means 5 divides a. Last time I explained you. Assume that as number 1 by theorem. Okay. Now let us take this a, as 5 is the factor of a, there will be another factor. So we see that a is equal to 5c, where c is an integer. Now since, take this equation, 5b square is equal to a square, right? And here replace a by 5c. So 5b square is equal to 5c whole square. 5c whole square is 25c square. Dividing by 5, it implies that b square is equal to 5c square. Now here again we see that b square is having two factors, that is 5 and c square. Hence 5 divides b square. It means that 5 divides b, or 5 is a factor of b. You can write like this also. Okay. Now this is the second statement. Now what is the first statement? 5 divides a and 5 divides b. This means that 5 is the factor of a and b, which we have already assumed that a and b do not have any common factor. So here what we are getting from first and second statement, 5 is the factor of a and b. So a and b have common factor. So that is not possible. Okay, let us see here. From 1 and 2, 5 is a factor of a and b, but it contradicts with a and b co-prime numbers. A and b are co-prime numbers. Hence our assumption that root 5 is rational is not correct. Hence root 5 is irrational. Now I have taken the second example. This is easier and simple it is. I am not taking a upon b. I am taking only a. You can take a upon b also, but that becomes rather confusing. So let us assume that 5 minus root 3 is a rational. Let 5 minus root 3 is equal to a, where a is a rational number. Okay. Now what we should do? We should arrange the numbers in such a way that one side should be the root form, that is irrational number, and the other side should be rational. See here, I have subtracted 5, means 5 is taken to the right hand side. 5 is taken to the right hand side, so it becomes minus 5, right? Now I am multiplying by minus 1. I want to remove this minus sign. So when you are multiplying by minus sign by minus 1, then signs get replaced. Positive becomes negative and negative becomes positive. Only this change happens because we are multiplying by minus 1. So minus root 3 becomes root 3, and this minus 5 becomes 5. I have written first, and a becomes plus a becomes minus a. Now what is the right hand side? Right hand side is 5 minus a, and you know that 5 minus a is rational. And what is left hand side? Left hand side is root 3, and root 3 is irrational. Is it possible that irrational number can be equal to rational? Of course not. So here I have written now, RHS side 5 minus a is rational and left hand side root 3 is irrational. That this shows that left hand side is not equal to right hand side. Means what? Our assumption 5 minus root 3 is rational is not correct. Hence 5 minus root 3 is irrational. This should be your line of thinking or method for solving such type of questions. Rest of the examples are based on this only. See now, try to understand on your own. Third example, 3 plus root 2 root 5. Again, let us assume that 3 plus 2 root 5 is rational. Let this rational number is equal to a. Now arranging the terms, taking 3 to the right hand side or subtracting 3, a minus 3, dividing by 2. So root 5 is equal to a minus 3 upon 2. Now a minus 3 upon 2. Right hand side is again this one a minus root 3. So right hand side. Right hand side a minus 3 upon 2 is rational, and left hand side root 5 is irrational. So hence left hand side is not equal to right hand side. Hence our assumption 3 plus 2 root 5 is rational is not correct, and hence 3 plus 2 root 5 is irrational. Now in this example I have taken both the root forms. Very simple it is. Now both the root forms are there. Little different treatment we have to give. Again we start by the same procedure. Let us assume that root 5 plus root 3 is rational. Let root 5 plus root 3 is equal to a, where a is rational. Take any number to the right hand side. You can take root 3 to the right hand side, root 5 to the right hand side. Any one number you take. I have taken root 5 to the right hand side. R means subtracting root 5. So root 3 is equal to a minus root 5. So we get this left hand side root 3 and right hand side a minus root 5. Squaring both the sides. Now we have to square it here. So I have shown you here a square. And I am using a plus b or a minus b whole square. When a plus b or a minus b whole square is there, what is the formula? A square plus or minus. If it is plus, here plus will come. If it is minus, here minus will come. So plus or minus 2ab plus b square. A square and b square are positive. We can write like this also. A minus b whole square is equal to a square minus 2ab plus b square. You can write like this also. And there is no need to write. This is for your guidelines. So using a minus b whole square formula, square of a, minus is here, so minus will be here, and 2ab means 2 into first term into second term. So 2 into first term is a, I have written here, and root 5. So 2 root 5, and square of plus square of root 5, that will be 5. Now a square minus 2 root 5. Now what you do? Now there is a simple idea that here root 3 square is 3. Now what I have taken? I have taken 5, subtracting 5. I have taken 5 to the left hand side. So here 3 is there, 3 minus 5. Simply we have to simplify. 3 minus 5 is minus 2. And right hand side is a square minus 2. And again what I have done? I have arranged the terms. Now how to arrange the terms? This minus 2 root 5 I have taken to the left hand side. That becomes 2 root 5. And minus 2 I have taken to the right hand side. Our line of solving is the same. What is the system or what is the method? Left hand one side should be irrational, the other side should be rational. This should be very important. So here 2 is there, and 2 we have to take it to the right hand side, that is dividing by 2. So right hand side is a square minus 2 upon 2. Now this entire right hand side is a rational number. You know a is a rational number by assumption, and a square minus 2 upon 2. 2 and 2, they both are the rational numbers. So root 5 is irrational and this is rational. Can it be possible? Of course not. So right hand side a square minus 2 upon 2 is rational, as a is rational, and left hand side root 5 is irrational. Hence left hand side cannot be equal to right hand side. Hence our assumption root 5 plus root 3 is rational is not correct. Hence root 5 plus root 3 is irrational. Now same this last example, but here I have taken only the variables, I mean p and q. Procedure is same. Let root p plus root q be rational. Let root p plus root q is equal to a. What is a? Rational number. Now you take any of this root p or root q to the right hand side. I have taken root q to the right hand side. So right hand side become a minus root q. Squaring both the sides. So again root p square is equal to a minus root q square. And again we are using a minus b. So that is a square minus 2ab plus b square. I explained you in the last example. So we have squared it. And how to do? Square of first square of root p is p, square of a is a square, minus 2 into first term into second term. So first term is a, second term is root q, and square of root q is q. Now what I have done, I have arranged the terms so that I can get the rational one side, irrational other side. I have taken this entire minus 2a root q to the left hand side and p I have taken to the right hand side. Now you see the right hand side, a square plus q minus p. This and 2 we have taken down, 2a we have taken down, dividing by 2a. Now this right hand side is rational and root q is irrational. So we cannot say that both are equal. Hence our assumption that root p plus root q is rational is not correct. Hence root p plus root q is irrational. I have taken 6 examples, earlier 1 example, now these are 5 examples. So practice nicely again and again. This method should be followed. Then only you can do any or you can solve any question. Okay guys, thank you.